We start by comparing the given equation with the standard equation of the conic, which is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This implies that capital A is equal to A, capital H is equal to 0, capital B is equal to B, capital G is equal to C upon 2, capital F is equal to C upon 2, and capital C is equal to 0. Now we know that the general equation of the conic, let's denote it by 1, represents a pair of straight lines if the determinant with rows capital A, H, G, H, B, F and G, F, C respectively is equal to 0. Substituting the values of capital A, B, C, F, G and H, we get a determinant with rows A, 0, C upon 2, 0, B, C upon 2 and C upon 2, C upon 2, 0. And this determinant should be equal to 0. Now take half common from each of the three rows. We get 1 upon 8 times the determinant with rows 2a, 0c, 0, 2b, c and c, c, 0. And this should be equal to 0. 8 cancels. And now applying a row operation to replace the first row with the difference of the first and the second rows. Therefore, the determinant becomes 2a minus 0, 0 minus 2b and c minus c in the first row. And the other two rows remain unchanged. The value of this determinant is equal to 0. Now notice that in the third column, the first and the third elements are 0. Only the second element is non-zero. Opening the determinant around that element, we get minus c times, in brackets, 2a times c minus of minus 2b times c should be equal to 0. 2 cancels and this expression simplifies to c square times a plus b is equal to 0, which implies that either c is equal to 0 or a plus b is equal to 0.